On behalf of NAHEPcast and Department of Agriculture Meteorology, I welcome you all participants for this fourth day of the training. In this session, our speaker is Dr. Kripan Ghosh, who is a head Agriculture Meteorology Division, IMD Shivajinagar, Pune. He will talk on application of extended range forecast to cope with climate risk in crop production. His brief introduction: he has post-graduated and done PhD in agronomy from BCKVV, Kalyani, West Bengal. He started his job career in IMD from 1998. He is presently head of Agrimet division of IMD at Shivajinagar, Pune. Prior to that, from 2015 to 17, he worked in a northeastern region in a weather forecasting, then also looking after the agromet advisory services. Then he worked for a year at IMD New Delhi in a risk management institute. Then he worked in an international research institute for climate and society in Columbia University, USA for 6 months. So he is having a vast experience of forecast and its use in agriculture, more than 20 years practical experience, day-to-day experience in agromet advisory service and impact of weather on crop yield. So I would like to request Dr. Kripan Ghosh sir to start his talk. Thank you, sir. Welcome.
Thank you very much. So let me share the screen first.
Yes, sir.
So it is visible, I think so, correct?
Yes, sir.
Yeah, okay. Yeah. So first of all, the topic, I am privileged to talk to you in front of all the participants, as I have been informed that more than 400 participants, they are attending this lecture. If we consider this particular aspect on which the theme of this training course, if you consider that climate risk management, that is the future of your this agriculture as well as agromet advisory services. When we are considering agriculture, we passed through that green revolution, first green revolution during 70s, 72 to 74 more specifically, if we will tell how it has come with the varietal development. We jumped from our this indigenous varieties with this longer strain to our the dwarf kind of nature and many other activities, taking some genes which has been identified, and it has been started. After that, lots of applications were there, mainly your irrigation aspects, then pest and disease management, then fertilizer management and all. So when we have taken all these things, we didn't think of much about your weather aspects vigorously. So if we consider this agricultural meteorology, it is a bit new subject. Maybe you can consider that emphasis has been given to use to harness this weather aspects or atmosphere for the improvement in agricultural production. That is mainly for 20 to 25 years old, you can say. So if we consider this that increasing or doubling of farm income, what is the call taken by our respected Prime Minister sir, then two ways you see that doubling of farm income. Two ways we can do that. One is that by reducing your this crop risk, means your input cost of production, and at the same time by boosting your yield. Both the cases you have to identify the what kind of weather conditions are suitable for the crop, or other way, what kind of this weather conditions you should avoid to reduce your risk. These are the things. Now, the question is that when we are considering, the topic has been given on which I will be delivering, that is application of extended range forecast to cope with climate risk in crop production. But when we are considering extended range, here we have mentioned forecast, but almost world community, mainly this meteorological community, they are considering this one as climate prediction instead of this weather forecast. Why it is so? Weather means what we understand, we are considering that instantaneous weather atmospheric condition on a certain day or so. But when we are considering this climate means it is almost an average weather condition. So extended range means we cannot give that day by day weather forecast for this means weather condition for next 10 days, 15 days, daily basis. Because when we will be giving this kind of information, specifically for this tropical region, after 5 days, your quality will be deteriorated. And most of the cases, it will not be in usable form. So because of this, what we can do when we are going beyond the 1 week duration, then we are trying to identify a single value for 1 week itself. Means when we will be telling for next week, subsequent second week, we will be giving that this will be the average temperature, maximum temperature, this will be the average maximum minimum temperature for that particular week, or this may be the average this total rainfall, cumulative rainfall for that particular week. So we are getting a single value for the whole week itself, for all the 7 days. So that's why instead of giving that weather condition on a certain day or instantaneous atmospheric condition, what we say, we are trying to identify what could be the average weather condition during that particular week, which is actually trying to predict the climate. So world community is trying to mention about that one as climate prediction. So initially, first I will be giving 10-15 lectures. I don't know that many of you may not be associated with that this agromet advisory services before. So what kind of this exchange range forecast we are using and how we are using for delivering to the farming community. And then I will be entering that how improvement we can do and how future scopes we are finding out, and we are trying to integrate with this agromet advisory services for its improvement, as well as for the improvement of the farming community, because you have to play a great role for towards this aspect. Now you see that if we consider that need of forecast of various scales for agriculture, what is so? First one is the seasonal or monthly forecast. What for it is required? This is the readiness and strategic planning. For example, when we are considering this monsoon months, it will be starting, for example, June onwards for a certain area. If your onset of monsoon will be taking place by 10th or 15th June, at a particular place, for a particular district, what the farmer wants to know, what will be the probable rainfall they are going to get in their district, more specifically for their farm, which is not possible for the this meteorological scientists to provide. So they want to know at least what is going to happen in their region, what kind of this rainfall they are going to get. So if they will be getting some idea that this year we are going to get less rainfall or normal rainfall or more rainfall, then they can select the particular variety or particular, or even the change the crop if there will be chance of less rainfall or more rainfall if it is not going to be normal. So for this kind of strategic planning, your seasonal forecast or even 1 month before also, if you will be getting this idea, that will be sufficient for them to identify the crop. So for strategic planning, to identify the crop, to identify that probable possible this sowing time and all these things, this information is very much required. What kind of season they are going to get ahead for their crop. Now, once this is fixed, they are trying to go for the input management. Means they will be getting prepared that at what time they are going to start it. So for that, this fortnightly forecast is very much required, mainly for your preparedness and tactical decisions. When they will collect the seeds, where from they will be doing it, whom they will contact, and all these things. Once they are ready with all these things, then comes actually this farm operations. So for that, we can consider that medium range weather forecast for 5 to 10 days, but in tropical countries, mainly in India, we are going up to 5 days with considerable forecast accuracy. Beyond 5 days, daily basis forecast, we didn't try till now. Nobody tried. And we can take about another this nowcast also, means 3 hours before, 3 to 6 hours we can say, but at least 3 hours before, so you'll be getting good idea that where it is going to rain. More specifically, at even at block level, even for a particular village, there is chance of heavy rainfall or this hailstorm or any kind of other events which may affect your crop, this kind of events. So these informations we can pass on to the farming community for their purposes. So first two, if we consider the seasonal and monthly forecast as well as fortnightly forecast, that is for planning purposes, and when it will be for the appropriate action or day-to-day operation that operational farm application. In that case, your nowcast and medium range forecast that is used. Now, what is the needs of the farmers or planners if we consider? Then local specific changes and variability in weather and climate. So their climate plays a role. Means if you are knowing that last 30 years or 40 years, what is the trend of weather condition? Means let us consider that if somebody will be visiting Shimla during the month of November, what they will do, they will be asking, if somebody will be there, if his friend is there, then they will be asking what could be the possible temperature. It doesn't mean that every year during that period the same temperature will be prevailing, but it will be general idea, because how much clothes, means winter clothes, they will be carrying with them, to get that idea. Similarly, the climatic condition, in which months we will be getting more rainfall. If we consider Kerala, rainfall starts during first week of January, no, first week of June for the monsoon months. That is the normal pattern. But if we consider this the western part of Rajasthan, it is going even first week of July itself. For example, first or second week of July, it will be getting rain, which will be helping to start your crop season. Similarly, the withdrawal will be during, means rain will stop by first or second week of September, normal pattern in most parts of Rajasthan, whereas in Kerala it is going even up to middle of October. So these are coming from your climatological knowledge. Climatological knowledge means what kind of climate uh, uh, is available at, means average weather condition is available for a particular season at a certain area. So if this information is available with the farmers, or this information is available with the planners, then it is possible to go for the planning for their crop season during that period. So climatic information is playing a major role to decide your crop or decide your cropping season at the beginning. Why it is so? For example, if your crop is not suitable, if your region is not suitable for a particular crop, so positively even the seed companies will not be mobilizing their seeds to those areas. So these are the things to be informed, or should be available in hand with the farmers as well as the planners at the beginning itself. Now, when the season starts, this is the planning purposes based on your climatic information, last 30 or 40 years of data. Then comes your appropriate season in a particular season, when you will start your own farming operations. What do you need? You need what I mentioned, extended range and seasonal scale of forecast, to decide what kind of crop or what kind of variety you will select. And once this is available with you, then you need to know when you will be going for the sowing of your crop. For example, you know that normal for a particular area, for example, if we consider Maharashtra, this sowing window varies from 15 June to 15 July for most of the crops in most of the areas. But during 15 June to 15 July, exactly when you will be sowing, that means when you will be getting that weather condition to sow your crop, suitable weather condition, that will be depending on your nowcast, short as well as medium range weather forecast. And many cases your this that extended range forecast, fortnightly extended range forecast is also helping. So now, along with this, the farmers need crop stresses and pest and disease condition and their prognosis. Then weather, climate-based farm management, what will be decided based on this climate information, and positively personalized advisories based on all these things, where the agrometeorologist playing the main role to provide the advisories to the farming community, what kind of farm operations they will be taking during that period. Now, I will give a brief history that how this agromet advisory services started in India. It will take hardly 2 minutes time. Even though it is away from today's topic, but this information is I think I must share, so that it will be easier for you to understand that how the requirement of climate risk management appeared. Now you see that first, the requirement of this weather information to the farming community, that has been felt during 1945, and along with that, IMD started providing farmers weather bulletin. Means every 6 hours the weather information what happened, as well as the weather forecast was provided to the farming community for a particular area, maybe at a district or at least at state level. That time it has been started. So it was going on for a longer period, 25 years itself. So 1970, there was this National Commission on Agriculture. This National Commission on Agriculture, they have given the report in 1971, and they suggested that it is very difficult for the farming community to interpret, because they have to know the terminology and what kind of forecast. Forecast is not given, was not given deterministic that time. So it was difficult for them to understand the terminology and translate this weather information into their day-to-day farm operations. So as per their suggestions, that they have suggested, along with this weather forecast, it should be interpreted by the agricultural scientists in terms of your suitable farm operations. Means under which weather condition, what kind of farm operations to be undertaken by the farming community. So as per that, from 1977 onwards, first is that it has been started from Chennai, that Agromet Advisory Service started. So it was going, that has been started at the state level, followed by Kolkata, and then it has been extended to many other states. But during 80s, there were subsequent droughts in 1982, then 86 and 87. So because of these droughts, it has been felt that some kind of more information, more stressed agromet advisory services should be started. Now you see, even a farmer, if he will be getting information 24 hours before, that what kind of weather he is going to get. For example, let us consider that there is chance of heavy rainfall, but he has already engaged his labor that for any kind of agricultural activities. For example, it may be sowing operation, it may be even spraying operation. So at least he or she will be able to save the input in terms of your seed or in terms of your that spraying this chemicals, means plant protection measures. But at the same time, he has to pay to the laborers because he has already fixed. So in view of that, if we consider this agricultural requirement, the medium range weather forecast, at least the information uh, available to them, if it will be available to them 4 to 5 days before, it will be easier for the farmers to take decision regarding any kind of farm operations, and they can completely save that particular loss if there will be any kind of event. So in view of that, the another separate organization that has been established mainly in 1987, you can consider during that period, that is called as National Center for Medium Range Weather Forecasting, who were mainly concentrating on your medium range weather forecast based on the dynamic models. That time dynamic models, it was giving information at about almost 200 to 500 scale, and there was shifting. uh, in view of that, 1991, first with 5 centers that Agromet Advisory Service started. That was started by this National Center for Medium Range Weather Forecast. That they have started at agroclimatic zone level. So both IMD's Agromet Advisory Service, that is at state level, and this agromet advisory services provided by NCMRWF through different this agromet field units established at state agricultural universities, that is at agroclimatic zone level. These two are continued simultaneously, and it continued almost up to 2008. 2005, Ministry of Earth Sciences has been formed, and the then secretary, he understood that two different agromet advisories are reaching the farmers, and that may be different also, because the forecast, the source of forecast for generating this agromet advisories are different. So if two different kinds of advisories will be reaching the farmers, there is chance that farmers may get confused that which this agricultural operations they will undertake. So one agricultural again, another committee has been formed in 2005. The committee has given report in during the earlier part of 2007, and from April 2007 onwards, these two services provided by IMD and NCMRWF, that has been merged together, and integrated agromet advisory services started. And under this service, uh, the first district level agromet, the district level forecast, that has been started to be provided from June, means monsoon 2008 onwards. And the along with that, the agromet advisories also that has been fine scaled to district level. So during that is in 11th 5-year plan. In 12th 5-year plan, our planners, planners and scientists, they got even more ambitious with the improvement in forecast ability, and the vision has been improved to reach up to the village level with the development, with the improvement of the forecast up to the finer scale up to block level. And with this, in 12th 5-year plan, the concept of Gramin Krishi Mausam Seva, which is the extension of the previous integrated agromet advisory service scheme, same scheme, which has been named as Gramin Krishi Mausam Seva, with the integrated, with the uh, uh, idea of reaching up to the village level. Now, this experimentally, it has been started from 2018 onwards. So, who are attached to this? For few districts, it has been made operational. However, it will be getting operational for other districts also. And around 2,500 blocks presently, these agromet advisories are being prepared by the scientists. Now, what are the these forecasts which are actually used? What are the forecasts which are actually used by the this scientists for preparation of agromet advisories? These are mainly nowcast, which is nowcast when we are saying that is at least 3 hours before, 3 hours before we will be getting the information, and that is very location specific for a particular block or district. What is going to happen, because this is mainly decided based on your this what I will say that radar image and all. So this will be very accurate. Then comes short range forecast for 72 hours, then medium range forecast for 3 to 10 days, whereas it is 3 to 5 days. Better to say this is 5 days in tropical region in the country like India. When you are going to the extratropical region, means beyond 30° north and all, the stability of weather is much better than the tropical region. And in European countries, in northern parts of Canada, or even northern parts of USA and all these areas, we are getting much more stable this weather condition, and it may go even up to beyond 5 days and even up to 10 days with greater accuracy. Then comes your extended range forecast for 4 weeks. Even though we are saying that it is 4 weeks, we can consider first 2 weeks the forecast accuracy is quite good. From third week onwards, it is getting diminished. The reason is that when we are considering this weather forecast, means this weather forecast for daily weather forecast at medium range or even up to 10 or 15 days, then it is based on mainly your initial condition. And when we are going for the monthly scale or seasonal scale, then it is mainly the boundary condition. But in between, means 15 days to 1 month, this period, it is most challenging, because during this period when you are going, then it is not giving that proper signal, and ultimately this is most challenging task for the the meteorology for the future period. Then comes your long range forecast for a season. Here, when we are considering long range forecast, it is very difficult to go beyond a certain limit. So in our country, we are giving it for only for the 4 homogeneous zones. We are giving for Northwest India, Northeast India, Central India, and Peninsular India. These 4 zones only we are giving that weather forecast. That too also only at the beginning of the month of June. And when we are giving the long range forecast almost 2 months before, then we can give only uh, for the country as a whole. Because as you are going ahead, means going away from your this period of anything else, means if you try to see anything else for 100-meter distance, and when you will be approaching to that particular target, your vision will be improving. So similar way, the correlation is diminishing as you are going away from the time of forecast uh, to a larger distance. So if you are giving the forecast during April for the whole month of June, there is chance that it will be having lesser accuracy if you will be giving in the month of May and at the beginning of the June. Because of this, it is the aggregation of the whole country itself, because ultimately aggregation of the larger spatial area, spatial region will be giving you better accuracy. That's why we are giving for the country as a whole. Now, at the same time, we are trying to give some early warning system also on extreme events. You know that presently we can predict cyclone even, uh, you can say that 5 to 7 days before, and with greater accuracy. Means hardly plus minus 50 kilometers range. We can find out that where it will hit and what could be the possible impact. Means with the wind speed as well as the amount of the quantity of rainfall. Similarly, when we are telling about the hailstorm or thunderstorm, positively, it will be only 3 to 6 hours before we can tell, because this will be very sudden development of any kind of weather phenomenon, and this radar image is required. Cold and heat wave, obviously, we can tell about, as well as drought. IMD is not giving any kind of prediction about drought, but we are giving about the persistence of the dry spell. Means how many days it will be, they will be getting the deficient rainfall. Drought is not declared by IMD. So cold wave and heat wave and dry spell, quite a long time before we can provide the information, and that can be utilized for preparation of agromet advisories also. Now these are different models, and what which are actually used for different purposes at different scales. I will not spend much time on this. Now you see that in our website you will be getting the weather forecast like this. If you will see that when you will be opening here, you will be getting that medium range weather forecast. Here you will be getting extended range weather forecast, and when you will be going to that, if you will go for 4 weeks product, you will be getting one by, or week wise product, you will be getting one by one category forecast. Means you will be getting that you are going to get rainfall below normal, above normal, or normal rainfall. Let us come here itself. um, Okay, we'll explain that one after explaining actual method of giving that this agromet advisories. So when we are considering that medium range weather forecast, this is at district level till now operationally. There, initially the model forecast is model output is generated at IMD New Delhi. That is our NWP division, numerical weather prediction, who are actually running that dynamic weather prediction models. This model outputs are going, these are collected, these are provided to our state agromet centers. For example, if we consider this Gujarat, it is Ahmedabad. Like that, in Telangana, it is Hyderabad. In West Bengal, it is in Kolkata. Like that, all the state agromet centers, they are receiving the model output from Delhi itself, and after that they are using the other model output as well as the previous weather condition, what is prevailing over that areas, and ultimately they are adding the value to that. All the 8 parameters, these are used. These 8 parameters are mainly rainfall, daily basis, then your maximum temperature, minimum temperature, maximum and minimum relative humidity, wind speed, wind direction, and cloud amount. These are the 8 parameters mainly on which they are adding the value. And after adding value for each district, the forecast is provided to agromet field units as well as district agromet units also presently. I will tell later on that what are the district agromet units. Agromet field units, I have already told that those are established, those started to be established by this National Center for Medium Range Weather Forecast from 91 onwards, and later on this has been started. When the integration has been done, this has been taken care of by IMD. All over the country, there are 130 agromet field units, and these agromet field units are mainly located in each in every agroclimatic zone. Only three are there, three agroclimatic zones, because of their variations. Those are having two that agromet field units each. Now, these agromet field units as well as district agromet units, when they are receiving this weather forecast, then they are mainly using three types of information, mainly your crop condition, crop stress, or the crop status, then past weather condition and forecast weather. Then based on this, with the help of the experts available at the university, or even if it is the KBK or the other agriculture organizations, they are preparing the agromet advisories for different crops under that weather situations, and then they are passing this information to the farmers. And once the farmers are receiving it, they are collecting the feedback, and this feedback is again help them to improve that what I will say, that their accuracy. that improvement of the this agromet advisories. Now see that how these forecasts are given. If you will see, these are the 8 parameters I have mentioned: the rainfall, maximum temperature, minimum temperature, like this, all the 8 parameters. And these are the 5 days starting from 20th July to 24th July. So these are the these 7 parameters. What was the forecast? So this was the structure almost up to 3 months back. You can consider from 3 months back. You can say that we started providing all the agromet field units and district agromet units after that particular day. For example, if we consider this weather forecast, 20th to 24th July daily weather forecast is given there. And after that, for the subsequent 1 week, starting from 25th July, we have given the weather forecast to the farming community. But one thing is clear here: when we are giving that weather forecast to farming community, this extended range weather forecast for subsequent 1 week, it is what I mentioned before, it is not possible for us to tell on daily basis. Then your forecast accuracy will be diminished. So what we have given, what we are giving in terms of your this category, means it will be above normal, normal, or below normal. That's why I have given here that there is possibility of above normal rainfall, or below normal rainfall, whatever it may be. This is the dummy forecast. This is the actual forecast I kept only for your understanding. So under these situations, if you will see that your this advisory will be changed. For example, if we consider 50 millimeter of rainfall is there, so as per IMD's norms, minus 19 to plus 19, or let us consider for calculation purposes, minus 20 to plus 20. This will be your normal weather condition. Okay, normal rainfall condition. So if you are getting 50 mm of rainfall, and if it is more than, means above normal rainfall, it will be occurring. So how much it will be coming? It will be positively more than 60 mm. If 60 mm rainfall will occur after 5 days, when you have already received around 100 mm of rainfall, means you need to go for your drainage facilities. That will be your advisories. Now you see that what will happen for normal rainfall, there also you are getting around 50 mm of rainfall, where you need to go for again drainage operations and all. But if your rainfall will be below normal, means it will be 40 mm or below, whatever it may be, it is not known. There may not be any action in drainage operation, but it will be the normal agricultural operations will be continued. Whatever it will be applicable, as per that the decision may be taken. So based on your this subsequent 1 week rainfall forecast, this will change. So this we have started just 3 months before, how extended range forecast can be maybe used for preparation of agromet advisories. So what kind of this management practices the farmers are taking? Already, I think so every of you are knowing that cultivar selection, sowing and harvesting dates, irrigation management, plant protection, and all. You are already accustomed to it. Now you see that what I mentioned before, how the agromet advisories are prepared using the past weather, using the quantitative medium range weather forecast. Why I am mentioning quantitative? If I will be giving only the qualitative values, means there is chance of moderate rainfall. If you don't know exactly what amount of rainfall you are going to get, that too also impact will be varying from for example, let us consider monsoon season. Impact will vary starting from your that beginning of the season, middle of the season, and end of the season. If there will be heavy rainfall during beginning of the season, it may not cause that much damage. How much it will be causing damage if it will be occurring at the end of the season, when all soil is already recharged. So you have to depend on the quantitative rainfall forecast information, as well as past weather when it is occurring. So along with that, you need to know the sensitivity of crop also. So if you are knowing the sensitivity of crop, past weather, and quantitative this medium range weather forecast, with that, along with that, if you will be getting that crop state, state means status of the crop, it is poor, normal, or very good growth, whatever it may be, as well as stage, then you can prepare the appropriate advisories based on all this information. So this is just what kind of advisories are given. This is one format. Now you see that how we are using that extended range forecast. This is mainly prepared in collaboration with ICR CREDA. How it is prepared? we are preparing that realized rainfall as well as extended range weather forecast. We are providing them rainfall as well as temperature. Mainly this extended range forecast, it is generated on every Thursday, and once it is generated weekly once positively, every Thursday. This information as well as that last 2 weeks what was the rainfall condition, that we are providing to Krida Hyderabad, and based on this information they are preparing that agromet advisories. So if you'll see here, let us consider 10th to 23rd September realized rainfall, how much it was there this year itself, that we have provided. This is 10th to 16th September rainfall, and this is the 17th to 23rd September. Now you see that what are the meaning of the color. If we consider, if as I mentioned before, this is the category forecast, mainly sorry, this category values means this deep blue color, that is your largely above normal, means more than 60% rainfall occurred over those areas. This is your mainly 20 to 60% rainfall. This is the sky blue color. When you are considering green, then it is below 20% and more than minus 20%. This is the range. This is the normal range. And then when we are considering red, that is your deficient rainfall. Deficient rainfall means it is going more than 20% to 59% deficient, means minus 20 to minus 59% rainfall occurred. And when we are considering yellow, that is your 60% to almost 99% deficiency. So this is actually the minus 60 to minus 99% deficiency. So whatever long period average you will be getting, as per that what actual rainfall you have received. So this is actual minus normal divided by normal rainfall multiplied by 100. So it is actually departure of rainfall in respect of your this normal rainfall over those areas, long period average, expressed in terms of percentage. Okay, so that way we are doing the similar kind of categories we are considering for our extended range forecast also. If you'll see here, now we have given that initial condition, what I have mentioned before, that normally during this when we are considering the first 20 or 25 days or 30 days, then we are considering that initial condition. So based on the initial condition on 23rd September, sorry, 23rd September, the rainfall forecast has been prepared and it has been provided. Here we are using mainly three criteria. That is, if it is more than 20%, then we are considering that excess, means above normal. If it is below 20% and more than minus 20, then during minus 20 to plus 20, this is considered as the normal. And when it is the deficiency is more than 20%, means minus 20% or less rainfall will occur, that amount of rainfall is considered as your this deficient rainfall. So if we will see, this is the rainfall forecast from this 25th onwards for next 2 weeks, 25th to 1st October, 25th September to 1st October, and then 2nd October to that 8th October. And similarly, we have given that forecast Tmax anomaly. Tmax anomaly means this is a departure of this temperature. Means if you will see that this scales, check it here. This violet color, what does it mean? If your temperature, this temperature, normal temperature of for a particular period, for example, here it is 25 to 1st October. If your maximum temperature is around 30 degrees centigrade, so this is mentioning that it is around minus 2 degree below temperature will be there. If we will consider this area, so it is around 2 to 3 degrees centigrade above normal temperature. Means if normal temperature over that area is 30 degree, then it will be around 32 to 33 degrees centigrade temperature will be occurring. Similarly for minimum temperature. So these forecasts we are providing to Krida Hyderabad as well as the rainfall situation during last 2 weeks. And based on this, Krida Hyderabad, they are preparing that extended range forecast based agromet advisories. So this is the present scenario, present situation where we are using this extended range weather forecast for preparation of our agromet advisories. But most of the cases we are using the subjective methodologies. So some measures that has been started, mainly if you consider that from you can if you can remember 2002 there was a vigorous drought in India which has reduced your crop production like anything. That was a drop in, I think, 81% rainfall was there, and because of that, there was huge loss. And again, it was followed by drought in 2009, 2012, like that. Now, because of this reduction in crop yield, the then Indian government, they have taken up one project that is called as extended range forecast and climate risk management in agriculture. So we'll come to those parts, what kind of development has been done, what objectives we are trying to perform now to integrate this kind of this kind of activities into our this advisory system that we will be discussing later on. First, let us understand what is climate risk and agricultural development. Okay. So normally, if we consider that any kind of this climate risk management, these are to be mainly crop model based, means climate and crop model based. Climate models means those are mainly your global model or regional model. Those are mainly used for your generation of weather forecast. And crop model is mainly integrated with the weather information. It may be the observed weather, or it may be the this weather forecast generated, or this climate prediction generated by the climate models. These are to be integrated with the crop model to get the information and ultimately to identify the scenarios or the options to avoid those kind of impact, means mainly climate change impact or any kind of this climate risk impact. To avoid those, this crop model information are very much required. Now, to estimate the impacts, what are required? First is climate change scenarios. One, what I told is those may be developed by your climate model. Then adaptive breeding. So if we will be getting the idea, even not only now, we are having some short-term planning, we are having some long-term planning. Long-term planning means you know that there are some IPCC report. If we consider northwestern parts of India, 3 to 5 degrees centigrade temperature may be increased during that 100 years. So if this kind of increment will be there, what kind of measures to be taken, what kind of adaptive breeding we will be taking. So along with that, when we are considering the short term this measures, if we are getting any kind of information through your fortnightly what I will say that exchange range forecast, or even monthly forecast or seasonal forecast. Along with that, we can decide that what kind of adaptive measures to be taken. If it will be at the beginning of the season, what I mentioned before, then we can even think of the land use strategies. So how we are confident enough present days to use this kind of information? Because previously, if we are going back 15 years before or 20 years before, our climate models or our crop models were not that robust, not that specific, not that it was not giving that much specific information or improved information, accurate information. But with the improvement in climate prediction system at a seasonal lead time, means for 2 to 3 months before, these are giving for the quite larger area, no doubt, but depends that how much this atmospheric condition, weather conditions are stable over those areas, the lead time is varying. So based on that, quite improved climate prediction we are getting even for a longer period. Then these are integrated with crop model to get the crop yield forecast under those scenarios. So if you know that this year you are going to get some different scenarios which may reduce your crop production, then as per that, you can go for that improved decision making ability with some farm management practices. So there you can integrate your farm management option, run the crop model again and again, and ultimately find out that what kind of this options it will be applicable for your area under this kind of change scenarios. So improved interventions will be helping you to take decision that how you will be improving, enhancing your livelihood and food security over a certain area. For that, this kind of this climate and crop model integration is very much required. Now you see that which farmers who are actually the risk averse. If we consider that farmers experience, they are not experiencing climate change as a shifting means. They don't understand. that if we will be telling them that your rainfall is affected by it is going to get 10% departure, 30% departure, 40% departure, they will not understand that. What they will be understanding, what kind of climatic variations they will be getting. We have to tell them this year you are going to get very less rainfall, बहुत कम बारिश होने वाला है, ठीक है, they will understand. So that way we have to explain these things to them. This is not only a shifting of mean that 15 mm, 40 mm, 30 mm rainfall कम होगा, means it will be less, it will be 15 mm or 30 mm less rainfall which will be occurring this year. Instead that it will be less, it is much lesser rainfall or excess rainfall or normal rainfall, that will be for their better understandability. Now, most concrete step to build resilience, how it is so proactive strategies to manage year to year climate variation. So you need to know your climatic pattern there. You may go for the return period of the drought. In how many years one that your drought may come back, or dry spell may come back, or flood may come back. If you will be getting all those informations, then as per that you can plan. So variations within farming communities using advanced climate information. So if you are having all those informations, so you can decide that what kind of crops you may grow at your area to reduce the risk. Okay, we'll come to that point, those points with better explanation abilities. Then integration of crop simulation models with seasonal climate forecast. So already you are having that climate information. Run the crop model for the previous years. You'll be getting the idea what could be the probabilities of getting what kind of production under which scenarios. And then when you will be getting the climate prediction during this year or recent or the forthcoming year, on that basis you can take the decision under different scenarios. So climate exerts a profound influence on the lives of poor rural population, on who depend on agriculture for livelihood and sustenance. If you will be having some other sources of income, so there may not be much problem. But if your this source of income is only agriculture, and that is also very much climate means weather dependent. For example, if we consider rain-fed agriculture in that dry farming tract, so there is high risk for the farmers to grow their crops. Then who are actually unprotected against climate related diseases also. At the same time, there may be food security. If you are not getting proper food, proper nutrition, the farmers may also be affected. Then who lacks secure access to water and food. I mentioned about food already, but at the same time, if there will be even 2 to 3 supplementary irrigation facilities also, then there may not be any need to worry. But if it is very difficult for even to get one single irrigation, then the farmers are getting worried to take any risk. Okay, and who are vulnerable to hydrometeorological hazards, all these things what I have mentioned. So year to year variability of rainfall is most hazardous, most important climatic risk for a farming community and for their farming system, you can say. Now you see, if we consider that about 60% of cultivated area over the world as well as in India, that is rain fed, you can consider. So if your rainfall is going to be less than 100 centimeter in a year in tropics because of high evaporation, then your the nature of your that what also that distribution of rainfall, all these things, if it is less than 100 centimeter in a year, positively there is chance of risk over during the crop growing season in any region. Then high overlap of poverty index and percent of rain fed area means at the same time the farmers who are already affected because of your poverty and all, it is very difficult for them to grow the crops. Okay, to take the risk. Once they will take the risk, and if they will not get the return, it will be very difficult for them to go back to take up the cultivation practices once again, because many of them are taking off these agricultural operations with loans and all. So science and technology, they are having very low impact on yield and profits from rain-fed farms where there is high risk is involved. Okay, why it is so? I will come to that. Now, climate risk users blind spot. First one is that what is this? Why does it or does not rain now? Means farmers are getting confused that it will rain or it will not if they are not getting any kind of information. If they have to take their own decision. Now, how will I manage my crop, livestock, and trees if there is X% chance of Y centimeter of rain during the period of this to this? Means if there will be no rainfall when already 7 days or 10 days dry spell is there, then they are liable to know if something, if there is any chance of getting rainfall or not. If not, how they will manage? If it will rain, how they will manage? So all these informations must be available to them, and they are confused when they are not getting it. Second thing is that forecast of how many days ahead the rainfall information or temperature or any kind of extreme event that will be available to the farming community. For example, if we can tell the farmers, consider cyclone, if we can tell the farmers 6 to 7 days before exactly that where it is going to affect, then they can take the appropriate measures. If we will be telling them one day before, they will go for this, go for saving their crops, or they will first save their lives. So this is depending also how many days before you can provide the information. And at the same time, similarly for temperature and all these things also, because minimum response time is required to take any kind of actions. Now you see what is happening during that condition. If risk is very high and the farmers is not having that proper information regarding that, so they are reluctant to use improved technology. So naturally, even though there is chance during that year to get very good rainfall, they are worried if something will happen, I will lose my uh, whole cost of production. So they are reluctant to use improved technology. They are reluctant to use fertilizer, proper fertilization. So naturally, they are going for underuse of fertilizers. And finally, they are shifting from productive to non-productive this farm production. So because of that, only to save their liquid assets. So if they are going to get 20 or 30% more yield, they had to be satisfied with the reduced yield itself. And ultimately, it's very difficult for them to increase the productivity of from his land ultimately to improve his income also. Now you see that for that, what is actually required? So framing climate risk analysis in agriculture, that is very much important. So why this climate risk in agriculture? And how you will be doing that? First one is that you need to develop a climate risk management tool. Means risk, climate risk matrix you have to develop for a particular area. How it is? So you have to, means this may be the farmer itself, he may be knowing his own place, or maybe the scientist through research and policy. First you have to go for research means you need to know for your own area. So if you will be interacting with the farmers, normally farmers information, farmers memory is not very long lasting. If you will be asking them, they may be telling about last 2 years, 3 years, or maximum 5 years, what happened during 2 years before, or the last event they can tell you. So if you will be getting the information, what kind of conditions they are getting, and if this kind of situation is there, you have to interact, what kind of risks they are getting. And if it is so, then you have to prepare all this in a particular format. If the rainfall will be uh, less during your this vegetative stage or your flowering stage, or even at the beginning of the sowing period, if it will be going beyond your sowing time, so these are the all you have to list out under a particular situation, and what kind of experience they are having in terms of your loss of, in terms of their loss of production, that also you have to document. And based on this risk climate risk matrix, so you are knowing that what is the sensitivity of the crop under which weather condition, and under which the soil impact and all these things. So when you will be getting all this information based on this climate risk matrix, you have to go for the research and analysis. And then you have to prepare one climate risk management tool. Means which kind of appropriate measures you have to adopt under which kind of climatic risks. So once it will be available with you, then you can run your crop model and check that, add one by one these options. in which year you are going to get lesser yield, and finally you can come out with some options to tell the farmers that okay, you can take this kind of appropriate measures. So climate risk matrix for farmers at the farm and watershed scale, what you have to do: user acceptable this climate risk means management. Farm context specific means we will be telling them something else which is not possible for them, so they have to accept also. It should not be very much costly ones what they cannot afford, or it is not possible for them to take up that what you'll be telling, bring something else from somewhere else, or introduction of a crop which is not acceptable at all there. So those are the things we have to avoid, and we have to identify some of the this climate risk management practices, considering their farm context, what is applicable, what is possible for their farm, as well as it should be acceptable by the particular end user. Then evaluating this CRM, what I mentioned also, you have to consider that cost benefit ratio, as well as if whatever you are saying, for example, you are telling them give irrigation under a certain scenario, and you know that your weather forecast is saying next 15 days it will not rain, but there may be some localized phenomenon. For a smaller area there may be some rain, most of the areas you may be correct, but smaller area there was very good rain where irrigation is your wastage. So what could be your penalty? Means whatever irrigation you have given, that is your loss. The other way also, if there is chance of rainfall, you tell the farmers he didn't take up he didn't go for irrigation, and there is reduction in your yield, so what could be the penalty? So all these things you have to calculate, and on that basis only the risk can be taken by the farming community for the improved yield as well as improved profit. So I think so third point also I have covered: implementing CRM in the climate risk management, that is what is acceptable and what is not. Role of others means here also not only the farmers, the experts who are providing the knowledge to them, their role is most of the important roles. Now you see that what I mentioned in the previous slide, similar way, climate risk, mainly crop, livestock and tree. What is their high risk plus most of it from climate? Means if there will be high climatic risk, farmer will not make additional investment due to high risk from multiple sources. So even if we will be suggesting them, the farmers are reluctant to do that, at least in Indian condition. But if you will be making them confident with your information, because what I told that there is much more improved information, may not be possible for a seasonal scale or monthly scale, but at least 15-day scale, quite good information we can provide at the subdivisional level. So if the farmers will be using it for a year or two and they will be getting confidence on it, they may take some kind of risks for improvement of their yield. Now, when we are considering that climate risk window where there is moderate climate risk levels, their actionable risk management options we have to identify what is possible and what is not, and availability of appropriate climate information if it will be there. Farmers may go for the risk, because why it is so, this is the moderate climate risk, means there may be some options, or the penalty may be much lesser as compared to the first case, because here we are mentioning, if you will see that high climate risks are involved. Okay. And the third one is climate risk, small part of total risks. For example, if we consider where there is very good rainfall, let us consider that Konkan region of Maharashtra. But there flood is a risk, no doubt, but risk is much lesser as compared to Marathwada or Western Rajasthan and all those areas. So here climate risk is not a that much factor for decision making. So here the farmers are much what I will say that much easy. This is easier for the farmers to take any decision for their farming operations. Now see that these are the extreme climate events where example cyclone, flood, drought, heat wave. So separate set of CRM needed uh, for these purposes. Here we didn't focus on this because these are not taking, because no extended range forecast can tell you regarding your cyclone, regarding your flood, or regarding a heat wave. Okay, because this is only giving you some kind of average weather conditions. So here really through extended range forecast you can't get the information through this. Climate events, for the climate events, we consider will include what are the things? Mainly moisture stress or water logging. So abiotic stress, why we are saying moisture stress? In the previous one we told about drought, dry spell, positively, because if already 7 days you are getting the dry weather condition, and another 2 weeks it will be showing that there is chance of large deficient rainfall or scanty rainfall, what we are telling before. Or other way, if you are getting very good rainfall during last 7 days, and again next 2 weeks it is showing much above normal rainfall, then there is chance of waterlogging. These kind of stresses, just I have given one or two, these kind of stresses we may consider. Biotic stresses, disease and pest, is it really possible for us to mention? Very few cases where it is very prominent. For example, if we consider that during first week of January or second week of January, eastern or northeastern parts of India, if there is chance of 2 or 3 degrees centigrade or 4 degrees centigrade above normal temperature persistence, means average daily temperature, if for 2 weeks it will be showing, and if we'll be getting humidity also is it's higher during that period, then there is chance of mustard aphid. So few cases where it is very prominent, informations are available to with us as per the thumb rule or whatever it may be, there it is possible, but otherwise not. Now CRM options, what are there? What are the climate risk events? First of all, for the crop itself, you identify the climate risk for a certain area. Similar kind of rainfall, for example, if it is 20 of rainfall, it may be a risk for rice, but it may not be a risk for your mustard or groundnut or something like that, okay, or her. Then farm plot context, you have to consider the similar kind of thing, 20 of rainfall or 25 of rainfall, very low lying area of rice, there water will be accumulated, that may not be under risk. But if it is the highland condition, then it may be under risk. So all those things you have to consider for your own purposes. So when do they occur, when it will happen, how important are they? So first, what I mentioned before, you have to calculate the cost if you will be taking this one. So if it will happen, what will be the benefit you will be getting? And if it will not happen, so for involving that cost, what penalty you are going to pay? Means whatever cost you have involved, if the event will not happen, then that will be your penalty. So benefit and penalty you have to calculate, and based on this economics you have to decide that you will be adopting that kind of climate risk or not. Then which option to choose based on all this information when you will be analyzing, and maybe for the experts that option is there involving crop model, then you can use those options, and finally you can decide that what kind of farm operations under different farm conditions, what you will be adopting over those areas. Already 1 hour. Now you see that year-to-year variations in the atmosphere are influenced by what? Interactions between the atmosphere and the more slowly varying ocean and land surface conditions. Such as, what is that? Maybe it is well known to you that El Nino or Enso, these kind of things we are considering, mainly in Pacific Ocean. They are near your Peru coast and all, okay? And then advances in modeling the global climate system and monitoring the this tropical oceans enhance predictability of climate this fluctuations at a seasonal lead time. So as this information technology through satellite, through even movement of your ship, through buoys, you are getting much more information over those areas. And this is actually, this El Nino and Enso, this is affecting your global circulation pattern, which is ultimately affecting your this rainfall pattern at different places. So as this modeling aspects, because of many reasons, that has been improved. So the prediction of the seasonal scale or monthly scale forecast, that is much improved nowadays. So these are the these information, this improvement in your technology, that may be exploited for your climate risk management purposes. Now you see that integration of climate and crop modeling, when we are considering climate risk management, I told you that climate model, what will be giving? It will be giving you the forecast, and crop model will be giving you that options to identify what are the appropriate measures for the climate risks. Now, what is the farmer's requirement? You see that farm scale studies have been identified severe resource constraints that limit responses to advanced climate information. It's really farm scale studies that has been given to you. Now, what is your main challenge to get the provision of relevant climate information? Then appropriate technical guidance and intervention in financial services and production inputs. Is it possible to provide climate information at farm scale? When you will be giving that forecast or even your this past weather condition, it's next to impossible because our technology is not that much improved that we can go up to the farm scale. Not even farm scale, when you are going for the monthly or seasonal scale, we can go up to the district level also. And at the same time, our observational techniques, observational network is also not that strong that we will be getting that information up to that level. So we have to go for that this coupling of this crop simulation with dynamic climate forecast. So what is that? The use of weather data from analog years. That is one of the possibility. You can identify the ENSO phase, and in those years, what was the possible weather in your region, and then coupling crop simulation model with the dynamic climate forecast. So identify those years, run your crop simulation model with your data sets of those years, and then try to identify what could be the impact in your area. So this is called the analog basis. But at the same time, if we will be going for that that with the climate forecast, so what kind of these things you have to do? That is, your assume the small scale of a homogeneous plot. Means your crop growth, when you are considering, that is your farm scale, means crop simulation model has to run at your farm scale. And farmers also need the information for its farm, and simulate dynamic interpretation between weather management and crop production at that level also. That too also daily time step. Means if you want to run your crop simulation model for next 4 months, you need the daily weather pattern for next 4 months, which is next to impossible. You can't give the weather forecast for next 4 months. This is the first thing. And second thing is that you that too also at your farm scale. Means you need to provide the this daily weather information for a particular farm, and with the inputs provided from that farm, integrate in your crop model, run it, then you will be getting some kind of information which you can utilize, which is next to impossible. Why it is so? Because our global circulation models, these are giving 10,000 kilometer scale. Now you can even get at 2,500 kilometer scale. What this general circulation models, this will be giving at the information at that level. But you can get the sub daily time step scale. Means daily many times it may run, and maybe it's 6 hourly information you can get. So what is happening for a certain area, it may give continuously many rainy days. In true sense, in your area you may be getting 7 or 10 rainy days in a month, whereas it will be the global circulation model, the output of that will be giving rainfall almost every day, but the quantity of rainfall is very less. So what will be the impact of that when you will be integrating with the crop simulation model? Impact is that where there will be high rainfall zone, there you will be getting a small amount of rainfall. Means intensity will be lesser, but almost every day. So it will be very good distribution of rainfall, which will be giving you the very good production every time. And on the contrary, where the rainfall is very less, what will happen there? There you will be getting very less, because rainfall is very less. So every day if you will be getting very less amount of rainfall, the rainfall will occur and that will be evaporated. So you will never get a good crop production. So because of this, when the general circulation model it is normally used, it is not considered the sub daily or daily steps of this weather information. The information, for example, rainfall every day or even sub daily scale, it is integrated, and cumulative rainfall for a month or for 15 days, it is considered as the rainfall for that 15 days. So that way it is considered. So that means we are getting the information for next 15 days, how much rainfall is going to occur, one value. Means the amalgamating this cumulative value will tell you next 15 days you are going to get, within this 15 days period you are going to get maybe 40 mm of rainfall, but individual days how much rainfall will occur, that is not possible to collect from the crop simulation, global circulation model information. So these are the two different aspects which we are getting from the climate prediction models as well as from your crop simulation models. Now, how to integrate these two? Uh, Now you see that translating climate, we'll come to that with some practical example that how we can do that. Now you see that crop models integrated with seasonal climate forecast provide a means of translating forecast of seasonal climate anomalies into forecast of production impacts. Means what is the impact, what is the anomalies is there, that we can take up and we can find out that what will be the appropriate impact on this. So the nature of decision determines the appropriate spatial scale and lead time of crop forecast information. So this will be helping you how much period ahead you can provide the information to the farming community as well as to the planners to take some kind of decision. So as we are going away from this, now here you have to take some kind of critical decisions because as per the farmers information requirement and scale of climate forecast. So what the producers of annual crops, what they want, range of critical decisions are taken prior to planting. I have already mentioned that what is going to be the rainfall during that period, okay, or uh, uh, what could be the distribution of rainfall. So at the beginning of the season we may not be able to tell about the distribution of rainfall, but whole season for next 3 months we can tell a single value that how much amount of rainfall in a particular agroclimatic zone will occur, or maybe at state level or meteorological subdivision level that will occur, that we can tell the farmers. But they don't know that really it will occur or not. This will be only experienced by them when they will harvest the crop. Okay, so if your predictability will be adequate enough to take the risk, then only farmers decision will be influenced by your this forecast. And that too also you have to decide based on the experience what could be your lead time. Means you can tell 15 days before or 1 month before or 2 months before. But what is the constraint here? What I mentioned, that a mismatch between the content, scale and format and lead time. All these things are providing some kind of constraints to provide this kind of information. So farmers information requirements are, you see that let us in the nutshell concretize the information here. Can be interpreted at a field scale, which is really difficult. Then we can go for some generalized information for a larger scale and maybe applicable for that region to provide the information to the farmers, and based on that they had to decide that what kind of risk they can take. It includes information about timing beyond 3-month climatic scales, is explicit about accuracy, and is expressed in terms of impact and management implications. So these are the things the farmers require, but which is next to impossible. In contrast, what can be given by the operational climate forecasts, that is typically expressed as 3-month climatic means averaged over larger areas. Means farmers need at their farm level, but we are giving at state or even agroclimatic zone level at the most, not more than that. So these are the contrary. So how we can help the farmers with this kind of information? I will leave this one. Okay, I will explain with this. Now you see that scale of any kind of this forecast, how it is varying. It is varying with your larger area. Why I told before, just in this slide, this is actually given 3-month climatic means averaged over large areas. It will be clear from here. When we will be giving that point means, let us consider not even point also, it may be a village or block level. You see, this is the January to March and this is the April to June rainfall for not in India. Yeah, I have collected this one. This is the prominent paper, and if you will see, the correlation is varying only from point 3 to 0.3 during January to March, and it is 0.6. Now you see that when you are going for 1 degree by 1 degree means 100 by 100, 110 by 110 kilometer. you see it is improved. Correlation is improved because it is going for the aggregation over a larger area, and ultimately your your impact of this variability is much lesser over a larger area when you are taking the average, and ultimately your skill is getting improved. Even when you are going for your 2 degree by 1 degree means around 100 to 220 by 110 degree, 10 kilometer, then you see that even correlation coefficient is even improving, your skill is even improving. And when you are going for the state or country level or the regional level, then it is even improving with the larger spatial integration. So this kind of information will be improving the skill of your climate forecast. But is it really useful for the farming community? So for that, some other techniques are really used for on which we have already worked out, and these are needed to be implemented with the improvement of the enhancement of the knowledge level of the scientists. Uh, okay, I will skip this one. Now you see, when we will be applying, let us explain this graph first, then we can go beyond the previous slides. You see that when you will be using this climate information, what I have shown before, it was around, go back here, it was around 60%, okay, 60 to maximum 65%. You see, similar way, this is October to December rainfall for Kenya itself. If we'll see that precipitation is this much, and in different years when we are considering how much it is varying, this is your that predicted is this one, and this is your observed, this black one. Now you see that what is the correlation of your predicted and observed rainfall, that is only 0.57. But when we have applied, means when this information, rainfall information, that has been applied over your simulated maize yield, means crop simulation model, you see that your this ability of crop simulation model to predict your maize yield, that is improved, that is your 0.85. Why it is so? Because when we are considering rainfall, then it is the one-to-one correlation, means rainfall observed versus rainfall forecast. But when we are integrating this rainfall information in your crop simulation model, there are many of the what we know, I think so that many of you may be knowing that information about the crop simulation model. Let us consider DSAT. DSAT is using 4 different types of this information. That is your soil information, crop information means your genetic coefficient, what is the crop variety and what is their types. Then third one is your weather information, and fourth one is your this crop management practices. So when we are integrating this forecast information with your crop model, in that case, what we are integrating? Only the weather forecast part. So 3.5 portion we can say means what will be your possible management practices, what is the soil initial condition, what is your crop variety, and what is their potential performance. These are information, these informations are already available with you. At the same time, if you are running your crop model at the middle of the season, a part of the growing period, the crop has already experienced observed weather situation, which is also known to you. So all this known information is improving your predictability of crop simulation model over your rainfall predictability. Means even though your rainfall predictability is 0.57, but because of this known information which are incorporating in your crop model, that is improving your crop simulation model skill. Now I am coming back to the previous one. What we have mentioned. We have mentioned that mismatch between the spatial scale of your this climate information, means your this climate forecast, as well as your crop simulation model requirement. Crop simulation model is required at your farm scale, and climate information is required at your climate information means climate forecast is available, climate prediction is available maybe at state level or met subdivision level. India is divided into 36 meteorological subdivision. Many states, for example, Bihar, it is a single meteorological subdivision. Jharkhand is single meteorological subdivision. But when we are coming for the when we are considering the larger states, like UP, it is divided into two: West and East UP. MP is West and East MP. Maharashtra is in four. It is that Konkan and Goa, then Madhya Maharashtra, Marathwada, and Vidarbha region. Like that, 36 meteorological subdivisions are there. So we can presently this external range forecast is generated at this meteorological subdivision level. Now you see that some kind of downscaling means finer scale informations are generated based on this information and local level information, but it is very difficult to go beyond district level. At the same time, when we are going for the going at the district level, except some of the districts, many districts almost we are getting uniform cropping pattern, or we are knowing that major soil situation. So take the major growing variety, take the major soil situation, and then use this climate information as well as that observed weather condition and run your crop simulation model. That will help you to get quite reasonable information about your crop yield forecast. Now, one thing is still unanswered here. How you will be getting that daily weather sequences, daily weather information? Because what we mentioned, climate forecast, climate prediction will be giving you a single value for next 3 months. That too also in the larger scale. So for that, there are many statistical methods which is generating that weather daily weather sequences for your longer period. Okay, maybe 2 months, 3 months, or monthly scale. Now, thing is that these this weather generators, these are called as weather generators. I will mention in your this forthcoming slides. These weather generators are giving the daily weather sequences of weather information. So now, as these are based on your statistical methods, if we'll be taking only one weather sequence generated using the statistical method, that may be erroneous. So what is the normal practice? Around, you can consider that maybe 200, 300, 500,000, this kind of weather sequences are generated. Then the crop simulation model is run with all these weather sequences, and the average of this, it is taken into consideration to reach up to that level, to understand that how many weather sequences are minimum required and what kind of information you will be getting. Now you check here, the x-axis, it is showing that how many weather sequences has been considered. Means if we consider that we are having that this climate prediction for June, July, August, September for Gujarat itself, Gujarat region. So daily weather sequences are to be generated for Gujarat region, or even downscaled for one district of Gujarat or something like that with the climatic information. This will be, you will be getting a single value. Then based on that, you have to generate the weather sequences from 1st June to 30th September. For all the 122 days, you have to generate this weather sequences, and that too also maybe number of weather sequences. So here let us consider we have taken 1,000 weather sequences like this, and then all these weather sequences has been run with the integrated with the crop simulation model. And for a particular crop, let us consider maize. Here we have shown the authors, they have shown that the maize have been this maize model have been run with all the weather sequences. Now you see that when we are considering only a single weather sequence, what is happening? It is showing very high RMSE. Okay, and at the same time your correlation is very less. Okay, when you are considering one. So as we are going to increase the number of weather sequences and we are taking the average, you see that your accuracy is increasing with your observed one. Correlation is improving. Okay, RMSE is reducing and correlation is also improving. And here you can see that almost after 100, even if you are increasing the weather sequences, then the correlation is almost remaining same, and your RMSE is also remaining same. So we can consider, if we will be taking 100 weather sequences for that particular region based on your crop climate prediction, and then we'll be generating that 100 weather sequences using that particular methodology. then and run with the crop simulation model, you will be getting reasonable this yield prediction. Once that will be decided, then you can add your this management options into this, and then you can decide what could be the appropriate risk management measures for that particular scenario. Now see, what I told before, that in 2002 there was very vigorous drought, and because of that in 2004 onwards, in collaboration with IIT Delhi and IMD and many other organizations, 9 universities were there. Even Anand Agriculture University was one of them, Coimbatore University in Himachal Pradesh, and Akola, many, 9 places, 9 agriculture universities participated in that particular program for development of climate risk matrices for major crops of their own districts. Then that weather sequences, the methodologies, development of methodologies for generation of weather sequences, downscale positively, previous to that, prior to that, downscaling of your climate prediction for a particular that particular region, and then that temporal downscaling means weather sequences are to be have been generated, that methodologies have been prepared, and then linking with crop simulation model that has been so with these objectives mainly that project has been taken care of. Now under that, even it is still going on, because that time, even though that has been that concept has been taken, that particular project that has been started from 2009 onwards, and the skill of ERFS, skill of climate prediction, that was not that prominent during that period. Scales are also much larger, but methodologies, the main idea was to develop the methodologies. How it is so? You just concentrate on this. First one is that climate prediction is there. So climate predictors will be helping you to downscale the rainfall forecast to a smaller spatial scale. So once this will be done, there are many methods. I have just mentioned 2 here. One is stochastic disaggregator. The other one is your non-homogeneous Markov model. Okay. So these will be these methodologies, these weather generators. These are helping this downscale rainfall forecast. Means, for example, it is mentioned a particular region will be getting 60 mm of rainfall, 60 centimeter of rainfall during next 3 months, June, July, August, or July, August, September. So that amount of rainfall, considering the criteria of that means the rainfall pattern of that particular region, this will help to generate that daily weather sequences for those 3 months. And then these 3 months, once this will be generated, this will be integrated with the incorporated in the crop simulation model, and then yield prediction will be done. This is one of the methodologies. The other one is that we will be generating, means the crop yield prediction was generated based on the information coming from the different years. And once that has been done, then the climate predictors which was directly used for climate rainfall forecast, as well as climate rainfall prediction, as well as that downscale rainfall forecast, those predictors were correlated, or regression equation has been developed with to develop the statistical model and to reach up to the that predicted crop yield forecast. So this is helping in other way. How it is so? Sometimes it is giving very good prediction skill. Why it is so? Because in between, when we will be going one by one step, it will be, if there will be any noise at the first scale, that will be aggravated. But here, as only one scale will be there, one step will be there, the noise will be much more reduced. So this is the methodology, how it is, why, how this concept has been conceived. You see here, why the linkage to crop simulation model that has been taken care of. We know the seasonal climate forecast, correct? This seasonal climate forecast, it is for the one single rainfall value or maybe temperature average for next 3 months. And we know that crop simulation model also, with all the information, maybe the soil information of a particular district, then what is the major crop, what is the major variety, what is the genetic coefficient, all these informations you are available. What is not available, what is the gap? Gap is your daily weather sequence. Means what will be the daily weather, possible daily weather during this 3 months period, that is not known to you, but only you are having that cumulative value of rainfall during these 3 months. If everyday rainfall we will add, then we may be getting, we are supposed to get 60 mm of rainfall as per the climate forecast. So for this we need to use that daily weather sequences. So once this you will be able to generate, you can add to your crop simulation model and you will be able to run your crop simulation model. Then you can put your management option there, and with these management options you will identify which management option can improve your yield, and that will be your but crop yield forecast is the measurement of understanding that which management practice is ultimately giving you the maximum possibility of yield, and that will be your option for going for the risk management. Okay, so just we will take care of one method, that is your stochastic disaggregation. You see here, GCM means global circulation model. Ensemble forecast. Ensemble, what is this ensemble? Normally when we are considering this global circulation model, maybe 2, 3, 4 global circulation models we are considering. Why it is so? Each any no model will be working under all the conditions, all the situations. For example, some model may be very strong in these hilly areas, some models may be strong in this plain areas, some models may be performing well during dry years, some models may be performing during heavy rainfall years, like that if you consider. So if we'll be taking the model output from all these 4 5, then we will go for a that ensemble one. Means what is the ensemble? Means we will go for a forecast considering all these global circulation models together, that is called as ensemble forecast. Now thing is that what is simple ensemble? This is the simple average of all the model outputs that will be giving you the monthly forecast or seasonal forecast. The other way, it is called as super ensembles. You may get that multi-model ensemble, MME. You might have heard of this terminology. So MME means it is the average of all the model outputs of all these global circulation models. Now at the same time, when we are considering super ensemble, at each grid we are taking this weightage of each model based on the performance of that particular model at that area, and on that basis we are generating that forecast for each grid. So that is called a super ensemble. Now you see that when we are getting this monthly forecast, then we are using that stochastic disaggregator, this weather generator. This will be generating that weather sequences, maybe number of weather sequences will be generating, that will be added with your crop simulation model, and this will be giving the forecast under that scenario. Now you check with different management options and check that which management option will improve your yield forecast, and finally you will be coming to your risk management option. Now this is the weather generator. If you will see, you check here, this is giving maximum temperature mean on dry weather condition, maximum temperature standard deviation under dry weather condition. Similar way, maximum temperature mean over this wet weather condition, maximum temperature standard deviation under wet weather condition. So under dry and wet weather condition, this will be generating first your this parameter page. Means first you have to run your this weather generator. Let us go back. First you have to run this part with your this weather information, means past 30 years data of a particular area. So once this you will be running with this weather generator using this stochastic disaggregation system. This is actually second order Markov model. This is taking that random probability of all the 4 options. Means dry day followed by dry day, dry day followed by wet day followed by dry day, wet day followed by wet day. So these 4 conditions we are considering, and based on this, the model, the weather generator is run, and initially the parameter file, you can get the similar kind of file in your this what I will say, that DSAT model also, but there the different logics, different systems, different model has been used. So here under different conditions. First it is generating the mean and standard deviation, then all the probabilities are also being generated, and these probabilities and mean, this is the general mean, this is the mean under dry day and wet day condition, and then your probabilities, rainfall probabilities and all. Then considering all this, finally the this weather sequences are generated. So how it is generated? First, it is trying to match the total monthly rainfall. Means when we are giving that monthly forecast for example, for July month, July, August, September, I told that seasonal scale we will be considering. We can take at the monthly scale also. If July, but here we are targeting only the monthly rainfall scale. So for July, if we will be getting, for example, 15 centimeter of rainfall. So it will try to, here we have given June 45 mm, means 4.5 centimeter of rainfall or 45 mm of rainfall. So if we will target that one, first it will generate for 30 days that how many number of days it will be giving rainfall. Okay. So once this is generated, then it will be running number of times to reach uh, to generate the rainfall on different dates, and finally 95% of the total monthly rainfall should be covered. And once this is done, then rest of 5%, if you'll see here, rest 5% will be multiplied with the correction factor for each day. It will be clear from here. You see, first what it will done, what it will do, it will first generate the number of days, number of rainy days for a particular region. For example, 45 mm we have mentioned. So 45 mm, how many rainy days it will occur? Let us consider here 6 days. It has identified that there is probability that it will generate the rainfall. One weather sequence. In other weather sequence it may change. So one by one it will generate the weather sequences, number of weather sequences. So for 6 days, each day it will run and it will give some rainfall. And once it will reach up to this point, okay, so you see that 95% of the monthly rainfall, adding all these values, that has been covered. So this 5%, it will be multiplied for each day, and ultimately it will reach up to that monthly rainfall. It will be clear from here now. You see. So how it is covered? Every day it has generated some rainfall, then it has multiplied with this, and these blue values after multiplying with that 5% rainfall, and this when you will be adding, you will be reaching up to that 45 mm of rainfall. Okay. So once this has been generated, then these rainfall values that has been added with the that has been incorporated in your crop simulation model, and then the crop simulation model has been run. If you will see here, before that, you see, this is your observed that yield. Okay, observed yield either from the ground level if it is available with you, or otherwise what you can do, you can run with your this observed weather condition for different years and run with your crop simulation model, which will be your benchmark. Now, once incorporated for the previous years, you have generated for the diagnosis purposes with the daily weather sequences generated with the known values, known previous values. You run your crop model and check that how much relation you are getting with your this crop simulation model. Some of the cases it may be, and once you will be getting the confidence with the observed weather data, then only you will be getting the idea that okay, this model will be applicable at your own place. Now you see that if we will be giving the lead time June, how it will be done? Lead time we have given June start, means at the beginning of the June we will be giving that weather forecast for June, July, August, September. Correct? So at the beginning of the June, at the beginning of the July, and at the beginning of the August. And how you will be running for the forecast weather? Observed already we have run, and we have seen that your model is quite good enough to run your this weather scenarios which are generating, that is in good agreement with your observed weather, observed yield. So once you are having this one, then you have to go with the forecast this forecast weather parameters to run your crop model and to check that how it is performing. So you see how we are doing it. When we are considering June start, then January to May we will be getting the observed weather, and October to December we will be taking maybe the either the normals or variations will be coming from different years. That is another story. I cannot explain those many things here, but you must remember October to December we can get the that some kind of climatology. Okay, and forecast weather will be from June to September. Okay. Similarly, when at the beginning of the July, when we'll be giving 3 months forecast, July, August, September, then already June observed weather, you know already that weather that means weather happened, weather occurred, realized weather for June itself. So that's why what it was there from January to May observed weather, now it is 1 month ahead, January to June, and October to December will be your climatology, and July, August, September will be your forecast. Similarly, for August, when we are considering, January to July is your observed, and August and September will be your forecast weather, and October to December normally it is not known to you, so that will be your climatology. So with this, when you are running, you see that you are getting this kind of observed scenarios. Now you check here, June, at the beginning of the June, when you have given your forecast and you have run your model, your crop didn't experience any kind of observed weather condition. So your correlation between your observed yield and your, positively these have been done later on, your observed yield and your that forecast yield, that is your only 0.18. But when we went ahead with the this thing, July I omitted because space was not there. Now consider August. When we are considering August, already June and July observed weather that has been included, and much of your means your crop model is already knowing some of the information. So if you will see that your crop model, that is giving correlation of your almost 0.7. So that way your crop model will be, skill of the crop model will be improving as your this season will be advancing. That is your plus point. So as you will be going with the advancement with the season, your decision making ability will also improving because of all these things. And here also, if you will check the crop, this rainfall forecast was only around 0.25 or 0.3 or 0.35, because in tropical countries that's also a very good skill, but it has been enhanced a lot because of your advancement of the season. Now you see, as per the performance of the crop, what is happening based on the seasonal and sub-seasonal this forecast, we have run our management options, and based on the management options we can tell the farming community what kind of advisories we can adopt. Okay, so these are the forecast. I kept it here already, it is 140, I don't know. So if we'll see that this is the deterministic prediction, that is for June, July, August, September. Okay, 2020 we have taken. Only one I am just telling you. So June, July, August, September, this is the deterministic forecast. You see, this is actually percent deviation. 112% of the long period average for the whole country itself. And when we are going for the state level, for example, let us consider, it is Met subdivision level, this West MP, 13% deviation is there. Now 13% deviation means if long period average is your 60 mm, this is in June, July, August, for 60 centimeter. So let us consider how much it is. 13% deviation means again you will be getting 7.8 mm, 7.8 centimeter more, means around 67-68 centimeter of rainfall it is going to get. That is your, as per this one, but it will be varying from 9 to 17% of that rainfall value, means it will be around 54 mm to almost, you can say, 90 mm. In between it will vary, but what will be the midpoint? Around 78 mm. Okay, like that we can decide. So this will be your amount of rainfall which will be occurring there, but the same criteria that has been followed. And this is the probabilistic forecast. If you consider this one, what we will see, this area is going to get the above normal rainfall, but what is the range? Almost 36 to 40% above normal, this area. But this area is going to get more than 70% above normal rainfall. As per that you can decide. Now you see that criteria, this color, this is coming under below normal, but what is the criteria? Almost 36 to 40% below normal. Okay, But here, wherever this white color will be there, that is the climatology. Means it is very difficult to say it will be normal, above normal, or below normal rainfall. That much only I can explain here. It's very difficult otherwise to tell you more than this. So this probabilistic forecast, this will help you to decide that what kind of this advisory, sorry, forecast you are getting, and how you will be implementing that. I kept for June, July, August, September this uh, rainfall, and then similarly for July, August, September 2020, and similar way for temperature also. December, DJF means December, January, and February. This is the average temperature. For example, maximum temperature, deterministic. This is for 3 months, and this is for December itself. Now you see that range has been given. If we consider this area here, there is chance of temperature more than average temperature for next 3 months, means 90, almost 90 days. It will be more than 0.5 degrees centigrade. But it is very difficult to tell that how much temperature will be there on which date. This is the deterministic, which this is the deterministic one. So these can be also incorporated in your disaggregator, and weather generator can help you to generate the temperature part also, component also. Now here also probabilistic temperature forecast. You see that above normal, when we are considering this area, it is matching with these colors. So we can consider there is chance of 70% above normal rainfall, above normal temperature over these areas. Okay, like that you can interpret. This is the maximum temperature, this is minimum temperature also. Now, similar way, some this probabilistic forecast, to use the probabilistic forecast with these institutes, that University of Arizona, then International Research Institute for Climate and Society, that is at New York, then RIMES at Bangkok, and State Agriculture University and Government of Bihar. In collaboration with them, IMD has taken up one project during last 2 years before. For 2 years it is going on, and with the idea of implementing this one in to extend this one at the larger scale. What has been done? They are probabilistic forecast under 3 categories: below normal, normal, and above normal, that has been generated at monthly and fortnightly scale separately for two consecutive weeks. Okay, this is when we are considering that fortnightly scale, and these have been provided to the farming community, the probabilistic forecast. How the experiment has been designed, forget about that. I'm skipping this one also. Let us consider that the 4 farmers group have been identified. This farmers group, how it is so? The farmers group will be given the training, one set. So they will be provided the training and forecast also. Then one group will be given only forecast, one group will be given that only training, and the last one will be given, last will not be given anything else. Okay, so these 4 groups will be have been identified, and 2 different scenarios have been identified. Scenarios means this has been done for East Champaran and Darbhanga. These are the this flood prone areas, and Nawada and Aurangabad. Uh, those two are the districts where the drought prone districts which have been identified. And these 4 cases, the farmers have been provided with the training first. That one group, what I mentioned, 2 groups, in fact, 2 groups have been trained first, that how to utilize the that forecast information, probabilistic forecast information. So out of these 2 groups, one group have been provided with the forecast information afterwards, and the other group have been given training, but no information provided by us. And one group have been provided the forecast information but no training. And the 4th group, no training and no forecast. That way we are trying to understand that how the farmers could be able to get the information of their own, and if they will be getting the information, if they are not having the training, how they can interpret this one. So in that case, what has been done? The forecast has been generated. Have been generated based on this probabilistic one for next 2 weeks, that what kind of rainfall will be occurring in 3 categories, and that have been provided to them. Similar way, it has been given to them for at the monthly scale also. So it has been found that many of them could be able to use it, and that has been still continued. So some of the, now if we will consider this, when we are considering this climate use of climate information, these are the already techniques we are providing. Many scientists, they have been trained also, and we are expecting that we will be able to come out with some kind of integration of this system with our agromet advisory system. Now you see that when we are considering any kind of this use of extended range forecast, it's not coming alone together. So here it will be we are considering that agromet products for maximum temperature, minimum temperature for the previous period, what it is available with them. Then the some kind of this satellite images also, which are also available, NDVI, VCI, TCI, I'm not going to explain. And the standardized precipitation index for last 4 months, as well as the cumulative for the season itself up to that particular day. And also we are providing that forecast for next 4 weeks based on the extended range forecast for next 4 weeks. So these are the informations are available with the experts when they are preparing the advisories using that extended range forecast. These are the helping hand. And at the same time, through surface hydrology, if you'll check our this that main website at IIM New Delhi, you will get that rainfall information on a certain day, estimated, positively estimated based on the observed weather. And also we are keeping this information on daily scale for next 32 days based on the that ERFS forecast. But positively, if we are going beyond, if we are taking the daily scale, it may not be giving you that proper information. But as the cumulative rainfall information is going to impact, let us consider if we'll be considering 15 days. So here itself, it will be taking the information for all these days, and cumulative rainfall will be giving the impact on this. Okay, that way we can get the information. And finally, amalgamating all these things, there is possibility to cope with that using this extended range forecast to prepare that proper appropriate agromet advisories and providing to the farming community. Thank you very much.
Thank you, sir. There are some questions.
Yeah, sure, please.
What are the upper atmospheric conditions responsible for deficit rainfall over Rajasthan? And is there any future satellite specially for meteorological service?
I think this lecture should not be addressing this one. Okay. I am just giving a little information about this. What you mentioned about the question once again?
What are the upper atmospheric conditions responsible for deficit rainfall over Rajasthan?
It's very difficult to mention about this because you see that during different period of the year, different atmospheric condition will be there. But when we are considering this Rajasthan or even these northern parts of these areas, mainly rainfall is depending on your western disturbances. And when the situation it is coming, this is mainly your either this mid-level this cyclonic circulation or upper air cyclonic circulation, which is penetrating into your ground level, and ultimately it is giving rainfall. So during monsoon period also, sometimes it is happening that systems moving either from Arabian Sea or Bay of Bengal, when any kind of western disturbance it is proceeding towards Indian region, and it's because of this circulation pattern, the moisture feeding is there from your Bay of Bengal, sorry, from Arabian Sea. This is giving the rainfall over those regions. If it is not extending up to that region and moisture feeding is not there, then and it is continued for the longer period, then you will not be getting uh, rainfall during that period. The other way true, actually, you can identify the systems which will be giving rainfall. If it is not present, then it will be continued for the deficient rainfall period.
Is there any future satellite?
You see, future satellite means GISat is going to be launched within 1 or 2 years, I think so, and we are already in monitoring, in preparing that what I will say, that requisition. We are giving the requisition to that ISRO, that what kind of satellites, what kind of products will be generated from there. And both the ISRO and IMD scientists are working together to identify the products as well as the methodologies to be developed, so that immediately after that, that may be adopted and that may be incorporated in our advisory preparation.
There is another question, sir. Why in tropical region weather forecasting is challenging?
Yeah. It is not actually, if you are considering the topic, it is
It
going
is not
away from the
related.
topic. Okay.
The
Now
tennis
you
have
see that,
asked.
no problem, no problem. You see that when we are considering this tropical region, it is mainly the convective activity.
Hmm.
Convective activity means it is your ground heating, and ultimately it is causing that uh, let us consider the layman's concept. I don't know if I'll be using the terminology, it is very difficult for them to understand also. So because of this surface heating, it is called as differential surface heating, you can consider. So if any region is getting different character from the other surrounding areas, and that area is getting much more higher, the surface is getting much more higher temperature, then it will be causing some kind of low pressure, and ultimately this air mass is going upward, and that is causing some kind of, what I will say, that vacuum in those areas, and that
Yeah.
will be fulfilled. This is causing us convergence from the surrounding areas and upper level divergence. How to
Hmm.
explain without board that what is divergence,
Uh,
what is convergence? And this may happen very soon because of this high heating during that summer season as well as post monsoon season, and which may cause that happening of your this frequent convective
changes.
activities, thunderstorm and all these things, and very localized phenomenon also. It is not happening, because when you will be telling this one why it is challenging, then as compared to the this this extratropical regions or temperate regions, where you are getting continuously similar kind of environment, similar kind
Hmm.
of weather pattern, and
Persistence.
one, yeah, persistence. One system is taking 4 to 5 days to develop,
Yeah.
and once it is developed, it is persisting for 4 to 5 days,
Several
even
days.
10 days, and you can
Then,
monitor that in which direction it is moving.
hmm.
It is easier to predict, it is easier to monitor that track also.
Very good explanation, sir. There is another question. Can we use coarse scale rainfall or weather data in a crop simulation model for small farmers' field?
Actually, whole lectures I have delivered on that only. Okay, latter part, if you'll be considering that last half an hour, I tried to address that one.
Yeah, yeah.
So climate model means this global circulation models, normally it is going beyond 2500 to 10,000 square kilometer. Okay, and that too also single value for next 3 months or 4 months. But when we are considering crop simulation model, in that case, initially the concept was there, you can't go beyond your farm level. But present day, normally how we are addressing, we are considering that what I will say, that major soil condition of a certain area. Okay, then major dominating crop varieties and dominating weather phenomenon. Okay, so dominating crop varieties, and this if you'll be getting, and if you'll be getting that this weather information, observed weather information from different sources. So using this weather information to downscale your this climate information from a larger scale to at least district level. So district level soil information, district level crop information, and special downscaling of district level information based on your previous, that means observed weather available for the past 30 or 40 years. Once you will be getting that, what I have shown
Yeah.
one that slide where I have shown that parameter file,
Hmm.
where it will be under dry day and wet day condition, all the mean, then standard deviation, then your probabilities, all will be created by the weather generator. It may be your
Hmm.
this non-homogeneous Markov model or the stochastic disaggregator, or even the weather generator, what is used under the DSAT also. Okay, so these are first generated, and once this is done, this particular parameter file is used to generate your weather sequences. But as the statistical model is used here, means because of this, you can't use a single weather sequence for that particular period, 3 or 4 months. It will be generating one and you run it, you don't know that how it will give. So that's why you have to generate number of sequences, maybe 200, 300, 500, whatever it may be. Then you have to go for that moving average, take the average of 1, 2, 3, 4, 5, or maybe 200 or 300, and then go for that that correlation, that where you will be getting that plateau. Once you will be getting the plateau with the diagnostic features, you can decide this many weather sequences need to be generated to incorporate in the crop model and run it. So that is the normal concept for most of the cases.
Thank you very much. You have given very good lecture, extensive lecture on this topic, and we got first-hand information from the authority like you, sir. I am very much thankful from the organizer's point of view and from participants who are benefiting from your very informative lecture. I thank you again, sir. Thank you.
Thank you very
Now there
much.
is announcement at a 3 o'clock. There will be another lecture by Dr. Vyas Pandey, Anand Agriculture University, retired professor, and he will talk on impact of climate change on crops under different climate projection scenario, a case study of Gujarat. Thank you, sir.
Thank you. Thank
Thank
you
you.
very much. Thanks to you all. Thank you.